The jumper wire between the two poles of the breaker is most likely used to create a multi-wire branch circuit, sometimes abbreviated as MWBC. This allows two separate circuits to share a neutral conductor, saving on materials and space in the electrical panel. Multi-wire branch circuits are permitted in accordance with specific requirements according to National Electrical Code Section 210.4. B. National Electrical Code Section 300.13. B says that neutral conductors must be common to all circuit breakers for multi-wire branch circuits. Several safety considerations are involved. Firstly, overloading can occur. If one of the circuits on the multi-wire branch circuit overloads, it can cause both circuits to trip. Secondly, an open neutral can occur. If the neutral conductor is interrupted, for example, due to a loose connection, both circuits will lose power. Thirdly, arc faults can occur. Jumper wires can create additional potential points for arc faults. Other possible reasons could explain the jumper wire. The jumper wire may have been installed to allow for a future circuit to be added to the panel. It's possible that the breaker was miswired and the jumper wire was added to correct the issue. The jumper wire may have been added to balance the load between the two circuits. Recommendations include the following. Verify code compliance. Ensure that the multi-wire branch circuit is installed in accordance with National Electrical Code requirements. Inspect neutral connections. Check all neutral conductor connections to ensure they are tight and secure. Label breakers. Mark the breakers on the panel to clearly identify which circuits share a neutral conductor. Be aware of the potential safety considerations associated with multi-wire branch circuits and take appropriate precautions. When dealing with electricity, always prioritize safety and consult with a qualified electrician if you're unsure about any aspect of your electrical system. Understanding the function and safety implications of components like jumper breakers is crucial for maintaining a safe electrical environment. Here's a deeper dive into the specifics. Let's start with multi-wire branch circuits. A multi-wire branch circuit is a type of electrical circuit that shares a common neutral conductor between two or more hot wires. These hot wires are supplied from different phases of a multi-phase power supply, such as a 240 volts or 208 volt system. The primary advantage of using a multi-wire branch circuit is the reduction in the amount of wiring required. By sharing a single neutral conductor, you reduce the number of wires needed, which can save on materials and installation costs. This is particularly beneficial in large installations where numerous circuits are required. However, it's essential to ensure that the shared neutral conductor is adequately sized to handle the combined current from all the hot wires. The National Electrical Code provides guidelines for determining the appropriate size of the neutral conductor in multi-wire branch circuits. Now let's discuss National Electrical Code compliance. National Electrical Code Section 210.4. This specifically addresses multi-wire branch circuits. It outlines the requirements for these circuits to ensure safety and proper operation. Key requirements include that the multi-wire branch circuit must originate from the same panel board, and all conductors must be disconnected simultaneously by the circuit breaker. This means that if you need to work on a multi-wire branch circuit, you must be able to disconnect all the hot wires at the same time to prevent any potential electrical hazards. Another critical requirement is that the neutral conductor must be common to all circuit breakers in the multi-wire branch circuit, as mentioned in National Electrical Code Section 300.13. B. This ensures that the neutral conductor can effectively carry the unbalanced load from the hot wires. An unbalanced load occurs when the current draw on each hot wire is different. The neutral conductor must be sized to handle the maximum possible unbalanced load to prevent overheating and potential fire hazards. Safety considerations are paramount when dealing with electrical circuits, and multi-wire branch circuits are no exception. Firstly, overloading is a significant concern. If one of the circuits on the multi-wire branch circuit is overloaded, it can cause both circuits to trip. This is because the circuit breaker is designed to protect the entire circuit, including the shared neutral conductor. Overloading can occur due to excessive current draw from connected devices or appliances. It's essential to ensure that the total load on each hot wire does not exceed the rated capacity of the circuit breaker and the wiring. Secondly, an open neutral is another critical safety concern. If the neutral conductor is interrupted, for example, due to a loose connection, both circuits will lose power. More dangerously, the voltage on the two circuits can become unbalanced, potentially damaging sensitive electronic equipment. In a properly functioning multi-wire branch circuit, the voltage between each hot wire and the neutral conductor should be equal, typically 120 volts in a 240 volt system. However, if the neutral conductor is open, the voltage can fluctuate significantly, with one circuit experiencing a higher voltage and the other lower voltage. This imbalance can lead to equipment damage or even fire hazards. Thirdly, arc faults are another potential hazard associated with jumper wires and electrical connections in general. An arc fault is an unintentional electrical discharge that occurs when current flows through an unintended path, such as through the air or across a damaged insulator. Arc faults can generate extremely high temperatures, which can ignite nearby combustible materials and cause a fire. Jumper wires, especially if they are not properly installed or secured, can create additional potential points for arc faults. It's essential to use properly rated and insulated jumper wires and to ensure that all connections are tight and secure to minimize the risk of arc faults. There are other possible reasons for the presence of a jumper wire between the two poles of a breaker. It is possible the jumper wire may have been installed to allow for a future circuit to be added to the panel. This could be done as a placeholder, with the intention of connecting the second pole to a new circuit in the future. However, it's essential to ensure that this is done in accordance with the National Electrical Code and that the circuit breaker is properly sized for the intended load. It's also possible that the breaker was miswired and the jumper wire was added to correct the issue. This is less common, but it can occur if the initial wiring was done incorrectly. In this case, it's essential to identify the root cause of the miswiring and correct it properly to ensure the safety and proper operation of the circuit. Another possibility is that the jumper wire may have been added to balance the load between the two circuits. This is particularly relevant in multi-wire branch circuits, where the load on each hot wire can vary. By adding a jumper wire, the current can be distributed more evenly between the two circuits, which can help to prevent overloading and improve the overall performance of the electrical system. Finally, let's consider some recommendations. Firstly, verifying code compliance is essential. Ensure that the multi-wire branch circuit is installed in accordance with National Electrical Code requirements. This includes proper wiring methods, grounding, and overcurrent protection. It's also essential to ensure that the circuit breaker is properly sized for the intended load and that the neutral conductor is adequately sized to handle the maximum possible imbalanced load. Secondly, inspecting neutral connections is another critical step. Check all neutral conductor connections to ensure they are tight and secure. Loose connections can lead to an open neutral, which, as previously discussed, can be a significant safety hazard. Use a torque wrench to tighten the connections to the manufacturer's specifications. Thirdly, labeling breakers is important. Mark the breakers on the panel to clearly identify which circuits share a neutral conductor. This can help prevent confusion and ensure that anyone working on the electrical system is aware of the presence of a multi-wire branch circuit. Use a permanent marker or label maker to create clear and durable labels. Be aware of the potential safety considerations associated with multi-wire branch circuits and take appropriate precautions. This includes wearing appropriate personal protective equipment, such as safety glasses and gloves, and using insulated tools. It's also essential to de-energize the circuit before working on it and to verify that the circuit is de-energized using a reliable voltage tester. In summary, jumper breakers in multi-wire branch circuits serve a specific purpose, allowing for the sharing of a neutral conductor between multiple hot wires. However, they also come with several safety considerations that must be addressed to ensure the proper and safe operation of the electrical system. By understanding the function of multi-wire branch circuits, adhering to National Electrical Code requirements, and taking appropriate safety precautions, you can minimize the risks associated with these types of circuits and maintain a safe electrical environment. If you are ever unsure about any aspect of your electrical system, it's always best to consult with a qualified electrician who can provide expert guidance and ensure that the work is done safely and correctly. Remember that electricity can be dangerous, and it's essential to take all necessary precautions to protect yourself and others from harm. Furthermore, consider the potential impact of modifications or repairs on the overall electrical system. Changes to one part of the system can affect other parts, so it's essential to take a holistic approach and consider the entire system when making any alterations. This includes evaluating the load on each circuit, the capacity of the service panel, and the condition of the wiring. By taking a comprehensive approach, you can ensure that the electrical system is safe, reliable, and efficient. Also consider energy efficiency when evaluating electrical systems. Look for opportunities to reduce energy consumption by using energy-efficient lighting, appliances, and other equipment. This can not only save money on utility bills but also reduce the environmental impact of electricity use. Energy audits can help identify areas where energy efficiency improvements can be made. Finally, never hesitate to seek professional help when dealing with electrical systems. Electrical work can be complex and dangerous, and it's always best to leave it to qualified professionals who have the knowledge, skills, and equipment to do the job safely and correctly. A qualified electrician can diagnose electrical problems, make repairs, and install new equipment in accordance with National Electrical Code requirements. By relying on professional expertise, you can ensure that your electrical system is safe, reliable, and efficient for years to come.